Welcome to Data Engineering with Subhadip. In this video, we will take a deep dive into the internal architecture of Google BigQuery, exploring how it stores and processes massive amounts of data so efficiently. At its core, BigQuery has a decoupled architecture that separates storage from compute. This is the fundamental design principle that allows them to scale independently. The storage layer is powered by Colossus Google's distributed file system, and the compute layer is powered by the Dremel execution engine. Let's first look at the storage layer. BigQuery uses a highly optimized columnar storage format called Capacitor. Unlike traditional databases that store data in rows, Capacitor stores all the values for a single column together. Let's see why this is so important. In a traditional row-based system, data is stored together row by row. To get the average age, you have to read all rows, including IDs and names you don't need. With columnar storage, all age values are stored together. The query only reads the age data block, ignoring the ID and name columns entirely. This drastically reduces the amount of data scanned from disk. So the two main benefits of this columnar approach are I/O efficiency and better compression. You get faster queries because you read less data, and you save on storage costs because similar data is easier to compress. Now let's switch over to the compute side. BigQuery's query engine is called Dremel. When you run a query, Dremel converts your SQL into an execution plan and assigns computational resources called slots to do the actual work. For a large query, Dremel breaks it down into smaller, independent stages. It then assigns these stages to hundreds or even thousands of slots, which all run in parallel. Each slot works on a different piece of your data simultaneously. This massive parallelism is the secret behind BigQuery's incredible speed. But what happens when you need to aggregate data, for example, using a group by clause? This is where the shuffle tier comes in. Intermediate results from all the worker slots are sent to a distributed in-memory shuffle layer. This layer sorts and groups the data by the aggregation key before sending it to the next stage for final computation. This is a critical step for complex analytical queries. So let's review the entire lifecycle. You submit a SQL query. Dremel parses it and creates an optimal execution plan. It dispatches tasks to thousands of slots, which read only the necessary columns from storage in parallel. The intermediate results are shuffled, aggregated, and finally delivered back to you. To summarize, the key design principles that make BigQuery so powerful are its decoupled architecture for independent scaling, its use of the Capacitor columnar format for efficient reads, the Dremel engine for massive parallel execution, and the in-memory shuffle for high-performance aggregations. Thank you for watching this deep dive into BigQuery's architecture. If you found this useful, please like the video, share it, and subscribe to Data Engineering with Subhadip for more content. See you in the next one.